All right, welcome to our lesson on medians, altitude, and perpendicular bisectors. This particular one is a slightly abbreviated version. The point of this lesson is to learn about these three things: the median, the altitude, and the perpendicular bisectors, which are all going to be segments related to triangles. And let's jump straight into it. So the median of a triangle is a segment that goes from the vertex to the midpoint of the opposite side. When you hear the word median, I hope you think of the word middle, like the median of a road is the middle of the road. Each triangle will always have three medians, and so it's going to go from the vertex to the midpoint. Well, it's easy to identify the three vertices. How do you identify the midpoints? Well, if it's a midpoint, it's going to have to divide it into two congruent segments. So we will know it's a midpoint because it's going to be marked that way. If it's not marked that way, you won't know that it's a midpoint. And then we're going to connect the dots here from vertex to midpoint. There's one. Vertex to midpoint, there's two. Vertex to midpoint, there's three. Each of them is a median by itself, but each triangle will have three. Let's do the same thing for the right triangle. We'll identify the vertices, we'll identify the midpoints, and then connect the dots. Vertex to midpoint, vertex to midpoint, vertex to midpoint. Those are the three medians. Same drill, obtuse triangle, really no different. So no matter what, the medians of a triangle are always inside, as we're demonstrated here by an acute triangle, a right triangle, and an obtuse triangle, all having the same qualities there. Now, the intersection, do you see how all three of the medians of each of these triangles intersect at the same point? That point then is called a point of concurrency. That's where three lines intersect, or multiple lines intersect at the exact same point. And it's called a centroid, which is a really awesome sounding name. Don't you agree? Okay, so a median, it goes from a vertex to the midpoint. Midpoint. An altitude, when you hear the word altitude, what do you think of? Not middle, like median. No, you should think of height, like the altitude from an airplane or top of a mountain or something like that. So an altitude of a triangle is the perpendicular segment from a vertex to a line containing the opposite side. So here we go. Here is our a vertex, and if I'm going to draw a segment that goes to the opposite side, is that a right angle? No, right angle, right angle, right angle. Perpendicular is there. There's the right angle, and so it is the segment that makes a right angle. Again, we'll do the same thing for each of them. When you draw it, is it right angle, right angle, right angle? Where is it? It's right in there is where it makes the right angle. That's what it looks like for an acute one. A right one's a little bit different. If we start from the actual right angle right here, it's pretty straightforward. It's going to go to the opposite side, making a right angle. If we're trying to make a right angle from this leg over here, though, not a right angle, not a right angle, not right angle, right angle with opposite side. Notice that it's the legs themselves are the altitudes as well. Why is that? Because there's the right angle. The two legs of a right triangle are altitudes. That's an important thing to know. We're going to be talking about heights of triangles as time goes on, and the altitude represents the height of a triangle from any side to its opposite vertex. Now, obtuse triangles work a little bit differently. It doesn't work differently at all if we're talking about the obtuse angle, the vertex of the obtuse angle. But if we're making the altitude from this vertex over here, nowhere inside the triangle, do you see this, does it make a right angle? Okay, so we have to extend the side. You have to extend the side here in order to come up with a segment that's perpendicular. It'd be right about in there. There it is. It's perpendicular. Likewise, from this one over here, nowhere inside is it perpendicular, so extend the side. There is the segment that is perpendicular. So, altitudes are different based on what type of triangle you're talking about. If it's an acute triangle, they're always inside the triangle, as we see up here. If it's a right triangle, one of them is inside and the other two are legs. The two of the altitudes are legs. The one that comes from the right angle is inside. An obtuse triangle, two of them are outside, and then the other one is inside. If it comes from the acute angle, it's outside. If it comes from the obtuse angle, it's inside. Now, like the point of concurrency of medians, there is one here. The point of concurrency of all three altitudes is called an orthocenter. That's easy to see up here and right there. The vertex of the right angle is the orthocenter. It is outside the triangle here. We got to do a little bit of work here to come up with the orthocenter. It's way down here outside the triangles on this obtuse one. That's called an orthocenter, which is a pretty awesome sounding word as well. And the third type of segment we need to talk about is called a perpendicular bisector, which is a segment that does exactly what it says. It's very descriptive. It is a line, a segment, or a ray that is perpendicular to the segment at its midpoint. If we're talking about segments, remember bisectors will go through a midpoint. So in this diagram over here, do we have a midpoint anywhere? Yep, look, B is a midpoint of AC because we have two congruent segments. So therefore XY is a bisector, and it's perpendicular because of the right angle. Therefore, XY is a perpendicular bisector of segment AC. So when we're identifying perpendicular bisectors, we have to be looking for a midpoint and a right angle. Okay? Now we're to do this with respect to a triangle. A perpendicular bisector is like a median in that it goes through the midpoints. And it's like an altitude, but it's at a right angle, but it will not go through the vertices. So look how this perpendicular, this is the segment that's perpendicular, it's bisector. The length has no bearing at all here with a perpendicular bisector. But it goes through the middle, and it's the right angle. If we do that for all three of them, look at them, they bisect, or they intersect at a point of concurrency. And this one is called a circumcenter. Now, those are the three terms. By the way, the term bisect always reminds me of the word bicept. So I want you to draw down here to the right of this triangle here an arm with a big muscle. For me, please. A big bicep. There's two special cases. If we're talking about an isosceles triangle, the median is also an altitude and is also a perpendicular bisector. And median from the vertex angle of an altitude is all three. We see what it does here. It goes to the midpoint, it's perpendicular, and, well, if it's perpendicular and it goes to the midpoint, it's a perpendicular bisector. It does all three. Do you see how these two triangles are congruent? Side, side, shared reflexive side, 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 side. Or we could even talk about that these angles over here are congruent because of the isosceles triangle theorem. This is an angle bisector because those two angles are congruent. TPC, got all those things going on there. If you happen to be talking about an equilateral triangle, each median is an altitude and a perpendicular bisector. Equilateral triangle is isosceles with every pair of sides that you choose because they're all congruent. But each median, each altitude is also a perpendicular bisector. And an angle bisector. Don't need to forget. All right, these are the types of questions you're going to be doing. I'm going to have you draw some things for me, and then you'll be identifying some things for me. There end up being a couple of math things that we'll get to in class next time. But give it a shot. I'll catch up to you in just a second. What it's asking you to do here for number one is draw a median from A. A median from A is going to go down to the midpoint. So there's what the median looks like. I got my median in red. To go from altitude, it's going to go from the point up there down to the bottom, making a right angle. Because it's isosceles, the median and altitude are the same point. Segment AB, to have a perpendicular bisector, it needs to go through the midpoint. So make a midpoint, excuse me, and then make a segment. It doesn't matter really how long the segment is. A segment that goes through the midpoint and is perpendicular to it. So try that now for 2 and 3, now that you got an idea. Just drawing those 3 segments, make sure you mark midpoints correctly and right angles correctly. All right, here's what they look like. And the last part of this is just asking you, based on these conditions, to answer these questions. So give them a shot. All right, so these are the right answers. I don't know. You may have some questions. If so, you can come ask me. I'd love to help you. A lot going on. Get rest. Love you. Bye.